welcome to day 2 of the Pharma conference. I hope you've all been enjoying all the talks and workshops so far. I certainly have. Today we've got another fun-packed day of exciting talks, but before we move across to the first seminar, Harvey kindly invited me to speak about the CAMIS project for a few minutes. CAMIS stands for Comparing Analysis Method Implementations in Software, and I'm going to tell you a little bit about the project. It's a Fuse data visualization and open source technology project. So firstly, why is it important to be able to replicate results? A lot of us working in the pharmaceutical industry send our results to sponsors, to regulators, to marketing groups, and quite often people check whether we've got the right results or not, and whether they can replicate those results. So if they get slightly different results, they want to know why, and that makes us feel sometimes nervous if we can't replicate the results across different software. And I think when everyone was using SAS, you had the same input data set, you did the same analysis, you got the same results. Now we're using a lot of different software systems and a lot of different versions. It can cause a few problems with trying to replicate and get that 100% replication. So this can bring nervousness about using open source software. And there can be people that go, well, let's just carry on using SAS because then we can definitely replicate. But hopefully the CAMIS project can help with this problem. And what the CAMIS project wants to do is really demystify the observed differences that we find between software. We want to justify them and increase confidence in the use of open source in medical research. So the project increases the understanding and the awareness of analysis result discrepancies across the software. It demonstrates the methodology through examples, and we have all of these examples and case studies put into an open GitHub repository that you can look at, and we're trying to grow that repository and increase the quality and the quantity of information. And we also have a white paper on the repo that you can have a look at. And there can be many reasons that you get different results. Some of them are really easy to fix. Some of them take a lot of time, and that's where the CAMIS project hopefully can help. The first point is really about if you have a different input data set and then you do some analysis methods, you will get a different output data set. So make sure your input data sets match, and that can be hopefully easily fixed by using the same derivations. The second point is rounding often causes us a problem because the rounding in SAS and R or Python is done differently. So we need to make sure we specify how we're rounding and do that the same, or at least know that that's the reason we get the difference. The third one is interesting because we've found that sometimes you get an ambiguous statistical analysis plan. And what I mean by this is that if you say you're going to round your means to 3 decimal places, do you describe how you're doing that rounding? And really in an analysis plan, we need to be saying we're going to round using the round to even approach, or we're going to use the round up approach, and just be a little bit more specific about the analysis we intend to do. And that will go a long way towards helping replication between different softwares, making it really transparent of what you've done in your analysis. The fourth one is errors in your coding or bugs. And I have to say this has come up less often on the project than I think I probably thought it would when we started. But because we're trying to use very trustworthy packages, you know, there isn't those obvious bugs that are in those packages. If you find bugs, then, you know, reach out to the open source writers, and that should be easy to investigate and fix. But then we come to the last reason, and it's really true software differences. And an example of this could be where SAS is applying a continuity correction in your equation and R isn't. Both are okay. They're not one's not better than the other in certain situations. It might be, but you need to know what it's doing. And these are the things that take a really long time to research and find out at the very sort of methodological part of statistics, which what is the software doing, and is it doing something different to another software? So just a quick overview of what the repository looks like. We do examples in R, examples in SAS, examples in Python, and then we do a comparison. And so each of these clicks through to a more detailed page. We're trying to cover all the most popular analysis methods used in medical research. And you can see we're going into sort of more advanced things like MMRM, although there's a lot more work we need to do on those pages at the moment. You'll see there's plenty of gaps, and that's where we haven't got any information at the moment, but we're continually building up the size of the repository as we grow. This is an example page of what you might see, something like the Wilcoxon signed rank test, which software it's available in. And here we've got StatExact as well as another software. And you'll see where there's differences of what's available, or maybe something's just available in some packages and not others. And we've tried to tabulate it to make it really simple. And so please do go and have a look at the repository. You're welcome to contact me if you've got any questions or you'd like to get involved and help. And there's a few bits of information on here about other information you can get. And just to say a big thank you to everyone that's contributed to the project to date. I'm sure there's more companies than are listed here, but we couldn't build the repo without everyone contributing. So I really appreciate everything that everyone's doing. And the more information we get on there, the more useful it becomes, so that if you're trying to replicate your results, you can't find what the problem may be. Hopefully your first point of call will be to look at the CAMIS repository and see if anybody else has found the same problem. And it might have the information there explaining the likely causes for the differences that you're seeing. And that could save you a really lot of time trying to look into these things, normally under high time pressures. So hopefully it'll be very helpful to you. Well, thanks for listening to me today. And I'm excited now to introduce the next talk. So if you want to leave this room and move back to the lobby, there you'll be able to join the next talk, which is Responsive Regulation of AI in Drug Development by Tala Fakori. And Tala is an Associate Director of Data Science and Artificial Intelligence in the Office of Medical Policy and Centre for Drug Evaluation and Research at the FDA. So that would be really interesting. So if you'd like to leave, and I hope you've enjoyed the talk. Thank you.